Right, hi everyone, and today's video lecture is going to be on the premise of Lab 2 for ECNG 1009, which is based on more loops, arrays, strings, and files. Now the first section that we're going to be talking about is with respect to more different types of loops, which is basically going to be the while loop and the do-while loop. And then we'll move on to arrays, and then strings, and then files. So, for us to get started here, we need to make a new project. And if we're using Visual Studio 2017, we'll be making an empty project in particular. We'll give it a name, which is Lab 2. And then we'll add a source file in here, which is a C++ source file. We also give that a name, say Lab 2 as well. So, just to write a standard template for our source file here. And just make sure that it compiles. Alright, so we can see on the output window here that it compiles successfully and everything's okay. Alright, so let's start with respect to different types of loops. So the first loop that we're going to be introduced to here is the while loop. And how the while loop operates is that it's such that it's a while expression and then we execute certain statements. Until the expression does not hold true anymore, then the while loop stops and then other parts of the code will execute after the while loop. So a simple example that we can see here is, let's create a standard integer variable here named count. And we say while count is less than 10, we want to output what the count is. And we also want to increment count, so that way count changes. So that way once count starts at 0 here, we'll keep on incrementing by 1, and when count goes actually to 10, because we're not saying less than or equal to 10, this while loop here in particular is supposed to exit, because this condition here in the brackets is no longer satisfied. So it's no longer true, so that means the while loop will stop executing, and then the next line, which is underneath the while loop here, should execute accordingly. Just to give an idea when it's finished, we're going to put an output statement here for us to see that it's done. Now, in some cases, when you are running code in Visual Studio 2017, when you try to execute it, the console screen will just blink on screen and then just disappear immediately. If you actually want to see what the output is, in that case, when this happens, we put the getChar function here in particular. Alright, so let's build this. So we can see here that it succeeds, and let's run it and see what the output is going to look like. So our output here is basically where you see count starts at 0, and because count is less than 10 here, we output the current value of count, which is 0 here, and then we increment it accordingly, and we keep on doing the loop until this condition no longer holds true. So we start at 0, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. Sorry. And once we reach where count is equal to 10, count here is not less than and equal to 10 in the brackets. So once count hits 10, this condition no longer holds true, and as of such the while loop stops executing, and it goes on to the next condition or next statement in the program. This next statement is going to be our done, which is outputted to the screen. And as we can see here, the console screen shows the output of this accordingly. Now, what happens in the instance if we did not increment count? So let's comment it out here to see what happens accordingly. So we rebuild our project, and then we run it back, and we can see here it just keeps on going forever because this count variable never changes and the statement keeps on holding true for the while loop. And in doing so, the program will just keep on running forever. So, when using any sort of loop in particular, it is important that you have a change in condition for whatever this condition is here inside the brackets. So, once this condition holds true for the loop will keep on executing. But the minute when the condition is false, the loop will stop executing, and then the next line right underneath the loop will execute and the program will proceed as normal. There's also a way for the loop to never execute as well. So in this case, let's say instead of the starting value of count being 0, it's 15. Let's recompile the program and see what happens. So in this case, our program just simply outputs done, because 15 here is more than 10. So this condition here for the while loop will never execute. And the statements inside the while loop will also never execute. So we just ignore the while loop itself, and we just go to the next line in the program itself, which is supposed to be execute, which is done. So let's look at another example of the while loop itself. So let's say int count here is equal to 1. And let's have our running sum here. So we set our sum here is equal to 0. And then let's say while count is less than and equal to 5, we create a dummy variable here named x of type integer. And we say enter integer number. So in this case, we know which integer it's going to be because we're using count here to track the integer that we are currently at. And let's input the integer here into x. And then let's have a running sum here. So sum plus equal x is the same as if we said sum is equal to sum plus x. The plus equal sign just means we just add the results back into sum accordingly. And because we're in the loop here, we also need to make sure that we have a change in condition, so that way our loop can execute and terminate accordingly once the count statement that was in the while loop holds false. And then because we're doing a running sum here, we now want to output the running sum to the screen as our last instruction. And for just to make sure that our output remains on screen here, we need to have our return statement for our main function. So let's build this and let's execute it accordingly. So the first thing we can see here is that our cout statement inside the while loop, where it says enter integer number and then we output the count, is we're using the count here as an output to say, okay, we want to see the first integer that we enter, and then the second integer, then the third integer, and so forth. So let's say in this case, let's enter 10 as our first integer. And this means when we hit enter integer number 2 here, the loop has executed once here, and count here is incremented accordingly. So because count here is incremented accordingly, that means the next iteration of this loop means that when we hit enter integer number count here, this is going to be 2, because count now is 2 because of that previous iteration. And it will keep on going until we hit where count is less than equal to 5. I think in this case, when count is equal to 6, the loop should terminate and we should proceed as normally throughout the entire program. So let's say 11, 12, 13, 14. And okay, my program exited. So let's run this again, just to make sure that it runs properly. 10, 11, 12, 13, 14. Okay, so let's see how I can make my output still appear on the screen accordingly. So another trick you can use is that we can put a breakpoint here on the return 0, and then we can go and debug, and we can start debugging accordingly. So what this does here is that this loads the debugger for our program, and this should also mean that once the program hits that breakpoint, the execution of the program should stop accordingly. Right, so as we can see here, the execution of the program itself, indicated by this yellow arrow here, stops at the return 0 statement, while the program here is still running. So we actually can see that the sum of all the numbers here is actually displayed on screen here. So if we add up all these 5 numbers here as before, we can see we get a result for 150. And to continue, we just hit this play button here, named continue, and our program just executes and ends gracefully. And once we have no more further use for this breakpoint, we just remove it accordingly. Okay, so let's look at another instance of where we can use the while loop for different conditions. So let's make an outer variable here. And let's say while outer is less than or equal to 5. And let's make an inner variable here to represent our inner loop. And let's say while inner is less than outer, we want to output an incremented variation of inner. And then we want to also output a new line, which is a special character \n. And because we're still in this while outer less than or equal to 5, we need to increment outer accordingly. So let's compile this. And let's execute it and see what happens. So in this case, we can see here that outer here is 1, and then while outer is less than 5 here, this condition holds true. So inner here is still 1, but while inner is less than outer, so say inner here is less than or equal to outer, so it's 1 equal less than or equal to 1, which holds true. We output what inner is, and in this case inner is going to be 1. And then once this ++ here is executed accordingly, inner changes to 2. And in that case, inner here no longer executes here for this while loop, and we terminate this inner while loop accordingly. We then move on to the other statements, which is we need to output a new line, and we increment outer accordingly. The loop then executes again accordingly, where outer here now is 2. And inner here inside this loop is still 1, but while inner is less than outer, this will be where this is going to output 1, then 2, because the increment value occurs here accordingly, and then it will terminate again. So this is how we get a run-in output accordingly using the outer and inner loop in particular. So to slow things down for you, because we're seeing it from an output perspective, let's use a breakpoint here. We will start with debugging. So we're keeping the output screen here. So we know on the first iteration we're only going to get 1 if we watch the conditions here for outer and inner. If we continue one more time, because this loop does not finish until outer is less than or equal to 5, when that condition does not hold true anymore, meaning when outer goes to 6, that loop here will stop executing, and the entire program itself will just go to the getChar function and just end accordingly. So if we continue here, we can see that we now have 1 and 2 accordingly. And if we continue again, we'll have 1, 2, 3 accordingly. And we can keep on continuing as of such. And our program will stop executing accordingly at this point. So let's even break this down further to see what happens. So let's start with debugging again. As you can see here, we had 1. But notice here in the lower part of our window, we have an autos window, which is also referred to as our watch window. So let's switch to the watch tab here, and let's add the outer variable to our watch by highlighting it, and add watch. And let's add the inner variable here as well by highlighting it, and add watch here accordingly too, so that we can see what the values of outer and inner are accordingly as we're executing. So in this case, what happens is that we know that for the first iteration of the outer loop, and when we hit the first iteration of the inner loop, we're only going to see 1, because the only variable that we're outputting here is inner. But on the second iteration, because outer now goes to 2, we now want to slow down and see what happens here accordingly. So if we go on the debug menu, and there is a step over represented by F10 here. If we hit F10, we can see that this yellow arrow here indicates the instruction that is to be executed. So we now start here because outer has been incremented, so we go back here, and 2 here for outer is still less than or equal to 5. So we enter the loop. Inner here is now 1, and we can see here that the value of inner here changes because we have executed that line, but the arrow here indicates the line to be executed. When we watch it, inner here, meaning 1, is still less than or equal to 2. So once this loop executes, it will output inner, and then inner here is incremented. If we watch the output screen here, we can see that it's just outputted 1. So remember, this inner plus plus, what this does first is it displays the current value of inner, and then it increments it afterwards. This loop still is going to be executed, so our inner loop here is still going to be executed. And we can see outer and inner here are both values of 2. And that condition is still satisfied for while inner is less than or equal to outer. This line here will execute accordingly. So the arrow here indicates that this is the line to be executed. It hasn't occurred yet, as you can see on the output screen. So what we were supposed to see here is that the output is now going to be 2. And the output here is 2 accordingly, as of such. So this will keep on going on. So we don't need to keep on showing this for all instances. So we can just hit continue here. And continue again. So we're supposed to see 1, 2, 3. Then 1, 2, 3, 4. And then 1, 2, 3, 4, 5. And we continue. The program itself should finish at that point. And we can just close it off accordingly. So these are different ways on how we can execute the while loop in particular, using inner loops and outer loops to see how can they cascade together to form different sort of situations. Now let's look at another type of loop, which is going to be the do while loop. So the do while loop is where we say do and we execute a certain amount of conditions while we have it is do where we execute a certain amount of statements, and then it's while a certain condition is fulfilled. Once that condition is no longer filled, we no longer do those statements accordingly, and we then proceed with the rest of the program code. So let's actually type out an example code here to see how a do while loop works. So let's say we have int selection. And let's start our do here accordingly. Let's just close back my program here accordingly with return 0. and put our getChar function here. So let's say we wanted to make a selection, so please make a selection. First selection here is going to be addition. Our second selection here is going to be subtraction. Our third selection is going to be multiplication. And our fourth selection here is going to be division. And then we need to accept the input for selection here. And this is the first part of the do while loop. So the do here, which is the enclosed by these brackets, indicate the instructions that are to be executed once the while condition is satisfied. So we now type in the while condition here. So in this case we want to say while selection is not equal to 1 and selection is not equal to 2, and we keep on repeating this for 3 and 4. So once a selection that is not 1, 2, 3 or 4 is made, we'll keep on displaying this on screen accordingly. And once a selection is made, this do while loop will have been satisfied, and as of such, the conditions here will stop executing for that do while loop, and then we go on to the next part in the program. So just to let the user know which option was selected, and let's compile this. And let's execute it to see what happens. So the first part here is where we're going to have please make a selection, and we show our 4 selection accordingly. So let's say if we didn't want to type in 1, 2, 3 or 4, let's say we typed in 5. Remember, this while condition here is not satisfied, because the while condition is waiting for once you type in 1, 2, 3 or 4, so it to be satisfied, so that way these instructions can be executed accordingly, and then it can just display the output, meaning that the while condition is satisfied. So if we type in like A, it will just keep on going, and this is an instance of where our program will crash, because in this case this is the data type that is not matched, because A here is a char data type and we're expecting an integer data type, so our program will just keep on running forever because it doesn't know how to resolve this because it's 2 different data types. So let's rerun our program accordingly, and in this case let's see when we actually do type in number that is expecting, type in 3, our program here will execute and it will finish accordingly as of such. So I'm going to add a breakpoint here just for you guys to see that it does execute. Type in 3. And our program says you have selected option 3, and we just continue and the program is finished. Let's look at one other instance of how we can use loops. But in this case it wouldn't be a do while loop, it would just be a while loop. So one thing to note in this particular instance is when we're using the do while loop, the selection variable here must be declared outside of the do block. And if we actually did put it inside the do block here, it actually would terminate before the while condition executes. And it will be destroyed inside that do block, and it just won't work at all. This is why we need to put the selection variable on the outside of the do block. So let's investigate one thing here before we finish this section in particular. I'm going to type some code here, and there is an error, and we're going to investigate why is there an error in particular. So we have a counter here, and let's say while counter just remember guys, I am typing errors here as we're going. So we're going to start pinpointing errors in particular. Alright, so let's build this, and obviously it's not going to work. So we can see here that the build failed. And if we double click on our error listing here, so the first one we want to click is on the first error. We can see a nice white marker here points up, showing, indicating, okay, this is where our error lies. And in this case, when we highlight over it, it's expecting a normal bracket instead of squiggly bracket. So we need to change these. Let's recompile and see what happens. So it succeeds. Now, one thing to note when we're doing this. It is quite important that we keep our curly braces to indicate which parts we want to be executed inside the loop. So, once you don't have any curly braces, all this does is that it executes only this one line here accordingly for this loop. Same thing with the if condition here. The if condition only executes the next line. It doesn't execute a series of lines. So it is very good practice to keep the curly braces to know which lines belong to which parts. So each lines that belong to the while loop should be enclosed in this curly brace here. And we want to say this curly brace needs to end here. And then for the if condition, we want to put a curly brace here. And we also want to put a curly brace here accordingly. And the same thing for the else as well. Let's just close this. And tab this accordingly. Oh, one thing also to note, which is a nice and neat trick, we can highlight all our text there. And we can go and edit, advance, and there's this option here named format selection that will actually indent our code accordingly and make it look all nice and pretty and whatnot. Alright, so this should fix most of the errors. There's still one more error inside here which we're going to watch in a little bit of it. So once we run this, we can see we're not getting any outputs at all. Why don't we get any output? It's because if we watch our while condition here, it's never satisfied. So let's actually put a cout statement here just for testing purposes to know that we actually finished doing what we did. So when we run this time, we can see that the while loop has never executed. We don't have anything saying odd or even accordingly and so forth. It just goes straight to the done condition or the done statement. It just goes straight to the done statement, and as such the program just finishes at that point. So our first error here that we also need to rectify is that instead of this being more than, it needs to be less than. We now have our output here accordingly, which is 0 is, 1 is, and so forth. So we need to make sure that there is a space here for nicety, because we can't just like 0 is and 1 is. And logically, 2 isn't odd, 2 is an even number, so we need to change that statement accordingly. So let's put a space in here for these statements. Now the question here is, which one of these statements is going to resolve in our output here being even? We watch our if condition here to see that this is counter divided by 2, but we want the remainder is equal to 1. So in this case, if the remainder is 1, that means we have an odd number. Because we divide them by 2, we get a remainder of 1. If we get a remainder of 0 on the other hand, which is our else condition here, this means that our output should be even. Let's recompile our code and execute it. And as of such, we can see we now have a nice correct output accordingly. So 1 is odd, 2 is even, 3 is odd, 4 is even, and so forth as we keep on going. Okay, so that actually brings us to the end of do while loops. Now there are a series of challenge questions that are in the lab 2 document that I would like for you guys to try on your own and just for practice. I actually will assist you with the lab exam as such. The next section that we're going to be doing afterwards is arrays.